evening, all of you. Today I'll be explaining to you how to visualize the COVID-19 data. Okay, this data has been taken from European Center for Disease Prevention Control and its website. I'll start. I'll just tell you the basics. Okay, and then some simple visualization with this COVID-19 data. Okay, so I had to load these libraries, and then I had downloaded this CSV file and I had kept in my laptop, so I'm just loading that to raw_data. Okay, so this has got 61,900 rows and 12 variables. Okay, you can just see here. Okay, so we will just see the basics. Class, it tells it is a data frame. It shows structure of all the structure of the raw_data, column names, and then other thing is summary. You can see the summary of that, and this is a summary. So each column it is telling about that, and then you can see deaths, some minus values are there, so that is wrong, and cases also minus, and then here some N is not applicable is there, so we have to remove those things. So here also NAs are there, and this column name is very big. You can rename that. So I'll just show all these things initially. So you can just change the column name using the rename command. So this is contained. This tells you from raw data it is applied, or the data is applied to this command. Okay, so in the same raw_data, I'm just changing the column name. Okay, so the last column, that is very long one, we'll just change that. Okay, that is changed. You can see here that got changed. Okay, that is changed, and then you can again see what's the column name in the 12th one. It is changed, and type is character, and then one MDY function is there that you can use to make it into readable form in the R, the date, month, day, and year. Okay, and you're going to add a new column for that. Okay, yes, you are adding one new column named date_reported using MDY function, and just pasting these things to make it readable in the R. Okay, it is taking month, day, and year, and then making it readable for the R. And now you're going to find which all columns have got NA. Okay, not applicable. Which all columns. Okay, for that this is the command call names of raw_data and apply. Okay, you're using the apply function to raw_data columns. We get 2 tells it is column base. Okay, and which all columns have got in NA, any NA. Okay, that is to find NA. Okay, so these columns have got NA. Okay, so we'll remove that, and we'll remove that NAs. For that you are using na.omit. Okay, and you're going to store those into df_clean_no na, no_na. Okay, so you can see the size has decreased and number of rows has decreased. And now, as we have seen before, you want to remove the negative numbers in deaths and cases. Okay, for that you can use filter command. So we are finally storing df_clean, we are storing in this one. So we are removing all the, we are just taking the deaths greater than or equal to 0 and cases greater than or equal to 0. So you are removing all the negative values. Okay. So now this will be the data frame we'll be using. So again, this has got decreased. Okay. Now it has become 58735. Okay. So now this is to find the total cases worldwide. Simple sum of df underscore clean. Just type df underscore clean and then dollar, it will come. Okay. Okay. Size increase. Okay. Okay. I just close that and then I got the value. Okay. And then now I'm going to find total cases and maximum single day. Okay. By country wise. So how I'm using the df underscore clean. Now I'm using that one. Df underscore clean. I'm giving that. And then I'm grouping by countries and territories. That's a column name. Okay, countries and territories. Okay, I'm using that column name. I'm grouping by that, and then I'm summarizing. Okay, sum of cases. This is the function sum of some cases and maximum of cases you're finding, and you're arranging it in descending order based on cases sum. Okay, let us see that. Okay, you can see here. Okay, descending order, which all countries had maximum cases. Okay, and then maximum cases maximum on one day, which is the maximum. Okay, so it is only showing the first 10. Okay, and then by continent wise. Okay, this is to get it continent wise. So we'll just do that. So you're getting by continent wise. So suppose I had taken the raw data. Okay, before cleaning, then you can see you'll get one other roles. That's why we use the clean dot. We can see there's a df underscore clean. Suppose in the raw data we are sorting it by content. Okay, you can see other is there that had na. So when we remove the na, that went. Okay, we removed the na, so that's why the other went. Other had that all the rows with other had na. That's why the na didn't come in the clean data. Okay, I hope you understood why other didn't come in the clean data. Okay, suppose here once again I'm showing in the here only 5 contents are there. So if we have taken the raw data, you can see 6 contents coming. Okay, and just to find the symbol to find the total depth. Okay, and now we can again use the group by function to find the mean, standard deviation and all. So here group by data you're taking df underscore clean, and this is a column name, continent exp, and then you have to use a summarize function and count how many rows. Okay, and then mean this na.rm means to discard na if some na is there. So actually there's no na. I have removed the nas. So you can see here. See. This is the count total number of rows correspond to Africa, mean, standard deviation, max. Suppose if you take the row underscore data, then the other will also come, and you can see the change in the standard deviation and all. Okay, 18.6 is 18. So it is always better to use the clean data. Okay, otherwise it will change the values also. And then this is same. I had another to group by continents, and now we'll go to the plotting. Okay, suppose you want to plot based on the countries. Okay, the death cases and death and all. So you don't know how India is represented in the column, whether I is capital, N is capital. So you can just check it whether this name is present, IND, just like this, whether it is present. Okay, it is present, it will give you true. That is the command, India percentage in percentage. Okay, and the column. And to know which are the names present in the entire column, the command is unique. Unique tells you the country names. Okay, unique country names in the column. Okay, now what we are going to do, we are going to compare multiple countries. Okay, so we are going to choose China, Spain, Italy, USA and India. Okay, from the column. Okay, this is column countries and territories were China, and the rows which has China and all the columns. That's why comma nothing. Okay, like that we are going to choose China, Spain, USA and India. Okay, we will just choose that. Italy, USA, India. Okay, now I'm going to just plot the date reported and cases in India. Okay, using the ggplot. Okay, this is a command for that. Okay, so it is using the ggplot. Color is blue, alpha is for opaque, and these are all parameters for the ggplot. Okay, you can just, so till here is the command for that ggplot. Okay, so I'm just executing that. Now it has come in ind underscore cases. So to that I am adding one title to that, labs and then title. So I'm going to plot that now. So you can see, so this is the number of cases in India depending upon the date. Okay, so now I'm going to compare different the countries I selected: India, China, Italy, Spain and USA. Okay, so this is cases in India. Okay, so here next one I'm plotting the death. Okay, cumulative, that column has got the death. What are the, I made it small, that's why it had the explanation here. Cumulative number of 14 days, not death, it is cumulative number of 14 days of COVID-19 cases per lakh. Okay, so I'm going to plot that. Okay, okay, so now I have sorted by country and I'm going to plot the first one, and I'm going to plot for the India, and then I'm going to add the rest of the countries to this plot. Okay, so same from here to here. Okay, this is the first plot, and then rest I am going to add to that. Okay, I'm going to add, and now China. Okay, data, this is important. Data, where is the data coming? The data is coming from China one. That is the rows that have got the country name as China. So I'm going to add that. Now Spain I am adding, now Italy I am adding, US I am adding. Okay, now I have got the everything in this variable I have got. So to that variable I am just adding the title and I am going to plot that. Okay, or let us, before that I will just plot India and China alone, and I'll just show you how India and China, this is the variable name. You can see India and China. To India I added China. So let us plot that and see how it is going. Okay, I will just plot this in India and China. So this is the China red one, and the rest is COVID cases of India and China. Okay, As you know, initially it was there, and after that they didn't release much data. Okay, now suppose India, China, and Spain. Okay, so red is China and blue is India. You can see here given like that only. Red is for China and blue is for India. Okay, so now I'm going to plot for India, China, Spain. Okay, so you can see here red, and then the blue is there, but when the blue has this here blue you can see, but blue when came to green, the Spain, you know, the number went very high. Okay, so that blue color has changed to this one. That's what this is the blue color actually. Okay, you can see a blue. Okay, so now let us see the combined one how it will be. Okay, this is the thing. Okay, the red is there initially, and here in China, India, Italy, Spain, and USA. Okay, this is the combined graph. I hope you understood how you are plotting that. And then I have done for the continents also, just to know the different names in the continent column. These are the names. So I'm going to extract the rows that has got China, Asia, Europe, Africa, America, Oceania. So first I'm just creating a plot for Asia, and to that I'll keep on adding. This is the idea. Okay, this one is for deaths. Okay, deaths of Asia. See here as numeric deaths. Okay, so I'll just plot the deaths in Asia alone. Okay, then I will show the continents cases. Okay, so this is I'm going to plot the deaths in Asia. Okay, you can see ggplot. Asia is the data. Asia I have taken here. Asia. Okay, and then date reported and as numeric deaths. Okay, so I'll just plot this. Just color, fill, opaque, everything is coming. Daily COVID-19 deaths in Asia. Okay, I'll just plot that. No, this has come in this variable. I have to add the title and I'm going to plot it now. See, this is the deaths in Asia. Okay, and now I'm going to do the cases reported. Okay, per lakh on 14 day. Okay, so first is Asia plot, and to Asia plot I'm adding the Europe data. To Europe I am adding Africa data. To that I am adding America data. To that I am adding Oceania data. You can see. Okay, so just I'm changing the data equal to that only because I have started the data and kept. I'm just adding to that. Okay, so first I will show you. So combined one is this one, Asia, and to that I'm just title like of the continent. I'll just show you and then I'll go back. You can see the see it has come. So before that I'll show you why some colors are going behind. So now I'll just show you Europe and Asia alone. Okay, Europe and Asia. This is actually blue color. When blue color is going with the red one, it is showing this color. Just to tell you that I showed now only Europe and Asia. So what is the actual color here? Asia is blue. Okay, and Europe is red. Asia is blue, Europe is red. Now I'll show you Europe, Asia, and Africa. Okay, Europe, Asia, and Africa. The blue coming here, and green is also coming. You know, Africa cases are very low. Okay, and now I'm adding America also to that. Okay, you can see. Okay, America has also come. Okay, purple. Okay, and now I'll show again the final combined. Okay, okay, combined. Yellow is also come. Oceania will be yellow color. Oceania is yellow. That's where the yellow is come. Okay, I hope you understood till now. Just I was showing how to play around with the COVID-19 data. You can do a lot of things, but I just showed you the basics. I will just recap what I had done till now. I have taken the data from European Center for Disease Prevention Control, and I have played with this. I just showed the structure, column names and all, and then I told a method to change the column names and then converting the date format, and how to find which columns had NA here, this one, which columns had NA, and then how to remove NA and how to remove the negative values. How we found the negative values were there from the summary. Okay, and then I got the clean data in df underscore clean, and then rest I played around that to group by countries and group by continent, and I showed you the benefit of cleaning the data by there is difference in the standard deviation and all. Here I showed you the difference in the standard deviation if you use the raw data, and then I showed you the min max, and then plotting. I came to plotting. So what you can check whether one particular name is there using this command, and then you can find the unique names by using the unique command, and you can extract. Now I have selected 5 countries. You can take your own list, your own choice, no issues. And then I plotted the cases of India alone, and then I combined with other. This is for India alone. Okay, this is for India alone, and then I started another session for comparing with different countries, and similarly I did for continents also. This for the countries, and same way I did for what is yellow. Yellow is USA data. Okay, USA data is yellow. Okay, same way I did for the continents also. I hope you understood. If you got any doubt or you want any codes, you can just comment. Thank you.